So this is section 5.5. We're obviously behind again, so yay, videos. So real zeros of a polynomial function are also called real roots, and they're also the x-intercepts of the graph of the function. So any polynomial function cannot have more real zeros than its degree. So if its degree is 4, the maximum number of real zeros is 4. Now, we can determine the number of positive and negative real roots without ever having to solve. And this is called Descartes' rule of signs, and it was created by René Descartes, who is also a philosopher and a scientist. But if we have a polynomial function written in standard form, which remember that's a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus, and remember it just keeps going until we get a1 x, that's an x, guys, sorry, plus a sub 0, and that a sub 0 is the constant term. So the number of positive real zeros either equals the number of variations of the sign of the non-zero coefficients of f of x, or that number less an even integer. The number of negative real zeros equals the number of variations of the sign of the non-zero coefficients of f of negative x, or else that number less an even integer. So what does that mean? Well, let's look at this example here. We have x cubed plus 2x squared minus 5x minus 6. So we're going to count the number of sign changes. Positive to positive, that's not a sign change. Positive to negative, that is a sign change. And then negative to negative is not a sign change. So what we have is one sign change which means one positive real zero. Okay, now we need to decide about the possible negative zeros. So we're going to find f of negative x. And to do that, we're going to put negative x in everywhere there's an x. So we have negative x, the whole thing cubed, plus 2 times a negative x squared minus 5 times a negative x minus 6, which equals negative x cubed plus 2x squared, because when we square a negative number it's positive. Negative 5 times negative x gives us plus 5x, and then we still have the minus 6. So how many sign changes do we have this time? We have negative to positive, that's one sign change. Positive to positive, not a sign change. and then positive to a negative, so that's a second sign change. So we have two sign changes in negative f of x, which means we have 2 or 0 negative real zeros. So anytime we find the number of possible zeros, we always have to have that many or 2 less. Okay, I'm going to move to the next page. So this brings us to the rational roots theorem. So if we have a polynomial function of degree 1 or higher in its standard form, where each coefficient is an integer. So each coefficient has to be an integer. That means if they're fractions, we need to get rid of the fractions. Then, if p over q in lowest terms is a rational zero of f, p must be a factor of the a sub 0 term, and q must be a factor of the a sub n term. So, list the potential rational zeros. This is how this actually works. So p is all the factors of negative 12, because that's our a sub 0 term. So that means plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, and plus and minus 12. Our q's are all the factors of the coefficient of the leading term. So that's 3. So we have plus and minus 1 and plus and minus 3. Now we have to combine all those into p divided by q. So we're going to take all the p's and divide them by q's. If anything repeats, we don't have to write it again. So first, let's take all the p's and divide them by plus or minus 1. That gives us plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, or plus or minus 12. Now we have to take all the p's and divide them by the plus or minus 3, which is our other q value. So that gives us plus or minus 1/3, plus or minus 2/3. Fortunately, plus or minus 3 divided by plus or minus 3 gives us plus or minus 1, so we don't have to redo that one. We also have plus or minus 4/3. Plus or minus 6 divided by plus or minus 3 gives us plus or minus 2. That's a repeat. And 12s divided by the 3's gives us plus or minus 4, so also a repeat. So, the p over q here, what I'm about to underline, that is all the possible numbers that could be real zeros of this equation, 3x cubed plus 8x squared minus 7x minus 12. So how do we use all of this information to actually find the zeros? Well, first we should use the degree to determine the maximum number of real zeros. So remember, for any polynomial, the maximum number of zeros it can have in general is the same as its degree. So if it's of degree 5, the maximum number of real zeros we could have is 5. Now that doesn't mean we will have 5 real zeros. We could have some imaginaries in there. But it's a good place to start. Then we use Descartes' rule of signs to determine the possible number of positive and negative real zeros. So that can help us narrow it down some. Then, as long as the polynomial has integer coefficients, we are going to use the rational zeros theorem, which we just talked about. Sometimes it's also called the rational roots theorem. You might hear me say that because that's the way I learned it. But remember, roots and zeros are the same thing. So we use the rational roots theorem to identify the rational numbers that potentially could be our zeros. Then we can use substitution, synthetic division, or long division to test each rational zero. Each time that a zero is found, we repeat step 3 on what they call the depressed equation, which is what's left over after we do division. And remember, if possible, use factoring techniques because they're faster. So sometimes you might find a root, and when you do the synthetic division, we come up with something that's easily factorable. Well, factor it. It's much faster. Okay, scrolling to the next page. Let's try an example. So, here we have 3x cubed plus 8x squared minus 7x minus 12. And we already found the potential zeros. That was that horrendous list. But first, let's follow the steps we just enumerated. So the first thing is it's degree 3. So that means that the maximum number of real zeros is 3, the same as the degree. Okay, the second thing, using Descartes' rule of signs. Okay, if we look at f of x, it goes positive, positive, and then negative, negative. So we have one sign change. In f of x, which means one positive real zero. Okay, let's do f of negative x. That gives us 3 times negative x cubed plus 8 times a negative x squared minus 7 times negative x minus 12, which gives us negative 3x cubed plus 8x squared plus 7x minus 12. So we now this time go from negative to positive. That's one sign change. Then eventually we go positive to negative. So that's two sign changes. in f of negative x, which means we have 2 or 0 negative real roots. Remember, roots and zeros are the same thing. Okay, so we have that big list from the previous page. So we have plus minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12, plus or minus 1/3, and plus or minus 2/3, and goodness gracious, plus or minus 4/3. That's a lot of roots to check. Okay, we know one of them is going to be positive and 2 or 0 will be negative. So we can start by checking the positives first. And as soon as we find one of the positives, then we're done. Or what I usually do is I find f of positive 1, then negative 1, and I just go by pairs. Now remember, we have the theorem that says if we plug one of these in to our equation, a possible root, if we get 0, then that means that it's a solution and a factor. Whoops. So, if I plug in 1, I get 3 times 1 cubed plus 8 times 1 squared minus 7 times 1 minus 12, which gives me a negative 8. Okay, let's try negative 1 of negative 1. Okay, so f of negative 1 gives me 3 times negative 1 cubed plus 8 times the negative 1 squared minus 7 times the negative 1 minus 12, which gives me 0. Yay. That means that negative 1 is a 0 of that equation. So now that I've figured out that negative 1 is one of them, I'm going to do synthetic division. So remember, we put negative 1 in the box, and we write down the coefficients of our polynomial. So that's 3, 8, negative 7, and negative 12. Okay. Well, if I can find the cursor here. There we go. So we have, remember, we bring the first one down, so 3. Then we multiply by what's in the box and write it underneath the next term. So negative 3. Then we add. So 8 plus a negative 3 is 5. Multiply, negative 5. Add gives us negative 12. Multiply gives us positive 12. And add gives us 0. Which is good, right? We should have had a remainder of 0 because it was a root. Now, what does this leave us with? This leaves us with 3x squared, right? Because we started with a cubic, so that means that's squared, plus a 5x minus 12. Now, I can either continue with this new polynomial we have and all those possible roots, or I can factor. And I'm going to factor because for me that's easier. So that factors into negative 3x minus 4 times x plus 3, which equals 0. So from that, we get 3x minus 4 equals 0, or x plus 3 equals 0. So that's 3x equals 4, so x equals 4/3, or x equals -3. So all our roots are x. Remember, we had -1, we have -3, and we have 4/3, which works out perfectly with step number 2, what Descartes' rule of signs told us. We would have one positive real zero and either 2, which we did, or 0 negative real roots. I will pick up with the rest of this lecture in a new video so that they don't get too long. This one's already over 20 minutes.